Hello everyone, and I welcome you all to another video on our topic of statistical characterization. In the last part, we'll look at few statistical measures for characterizing dispersion. This is the second part, and we are going to look at certain more statistical measures in this one. We are going to understand these statistical measures by solving certain questions of first internal test, part A, statistical characterization. My name is Manas Pathak. I'm a student of IIPS DAVV. Let's start. So this is the question which we solved in last part. The question for today is, suppose that the student feedback rating on a scale 1 to 100 on faculty mentoring effectiveness is given in sorted order, and then we are given a data in sorted order from 13 to 70. There are total 27 frequencies in this data. Now let's see what the questions are. Part A says what is mean rating and what is median. So basically we have to find mean and median for the data. So the formula of mean is sum of all frequencies divided by total number of frequencies. Sum of all frequencies here is 809. Dividing that by total number of frequencies 27, we get the answer 29.9629, which is our mean value. Formula for for median for odd number of frequencies is the n plus 1 by 2th of the sorted order. That is the n plus 1 by 2th term of the sorted order would be our median. Where the value of n here is 27. So 27 plus 1 divided by 2 gives us 14. So the 14th term of the sorted order is our median, which is 25 here. Part B. What is mode of data? Comment upon its modality. Mode, as we know, is the most occurring frequency in our data. So in the given data, there are two most occurring frequencies, which are 25 and 35, which both of them appearing four times. Hence, we have two modes, which are 25 and 35, and our distribution is a bimodal distribution. Part C. What is midrange of data? The formula for midrange is the sum of highest and the lowest value of the distribution, dividing that sum by 2. So the highest value is 70 and the lowest value is 30. Dividing that by 2 gives us 41.5, which is our midrange. Part D. Estimate first quartile and third quartile. So to calculate the first and third quartiles, we are going to divide the distribution into two parts based on the median. The lower half would contain 14 elements, including median, starting from the lowest value 13 to the median 25. The first quartile would be median of this lower half. So median of these 14 values would be our first quartile. For even frequencies, the formula of median would be the average of n by 2 at term, n by 2 plus 1 at term. So the average of these two terms would be our median. These two terms here for the given lower half distribution is 20 and 21. So taking average of 20 and 21, we get 20.5, which is our first quartile. The upper half would consist of 13 values, starting from 30 to the highest value 70. The third quartile would be median of this upper half. As we know, for odd number of frequencies, the formula of median would be n plus 1 by 2 at term, which is 35. Hence, our third quartile is 35. Part E give 5-number summary of data. So the 5-number summary for any data consists of its minimum value, first quartile, median, third quartile, and the maximum value. Since we have already calculated the first and third quartile and median, we just have to find the minimum and maximum value of the distribution, which are 13 and 70, and we have completed our 5-number summary here, which is given in the slide. Part F, plot the box plot for given data. So box plot basically plots this 5-number summary on a graph. I have plotted this box. As you can see, here is my box plot. I have plotted this box plot using Python language, using Matplotlib library of Python, using function matplotlib.pyplot.boxplot, and I have passed the argument array. Here array refers to the numpy array containing our distribution. I'm quickly going to explain you this box plot. So the two whiskers at the two ends of the box actually represent the minimum and maximum values. Here you can see here's a small dot at top which represents this value 70, which is considered an outlier here. Hence the second highest value, which is I think 56, is represented by the maximum whisker, and the lowest value is here represented by the minimum whisker. As for the box, the top edge of the box represents the third quartile, while the lower edge of the box represents the first quartile, and the line in the middle of the box represents the median. Hence, this is our box plot for the given data. The last part asks us to differentiate between a quantile and a quantile-quantile plot. The quantile plot shows the qualities of a single data set against the corresponding fraction of the sample. So basically, a quantile plot would plot the data to their corresponding quantiles, while a quantile-quantile plot graphs the quantiles of one univariate distribution against the corresponding quantiles of another. So quantile-quantile plot would plot two different distributions corresponding quantiles. In a quantile plot, x-axis plots the fraction of sample, which are the quantiles, and the y-axis plots the values of the sample. While in quantile-quantile plot, the x-axis would plot the quantiles of one data set or a theoretical distribution, and the y-axis would plot quantiles of another data set. For quantile plot, a plot shows overall distribution of data set. In a quantile plot, the interpretation for a straight line would indicate that the two distributions are similar, whereas if the plotting line of a quantile plot is not a straight line, that means there are dissimilarities between the two distributions and they are not equal. So this was all about today's video. In the next video, we are going to understand how to calculate median for a continuous distribution. You can also check out the link for part 1 in the description of this video. I would like to give my sincere gratitude to Dr. Sairam Prajapat for their invaluable guidance. If you like this, if you gain some considerable insights from this video, consider liking this video, subscribing to my channel. I'll be coming up with more interesting topics. Thank you.